Hello, Professor. My name is Hamza Chow, and this is our semester project for CS 620 for me, Hamza Chow, and Dakota Scott. So, for the project, we choose to work with the NYPD arrest data for the year of 2023. So, this is the data set. It is a breakdown of every arrest affected in New York City by the NYPD during the year of 2023. This data is manually extracted every quarter and reviewed by the Office of Management, Analysis and Planning. Each record represents an arrest affected in New York City by the NYPD and includes information about the type of crime, the location, and time of enforcement. In addition, information related to suspect demographics is also included. This is the link to the data set. So our goal for this project is to create a predictive model to accurately forecast crime boroughs and types in New York City. This model will enable proactive law enforcement strategies, optimize resource allocation, and enhance public safety measures for residents and visitors. And it could even benefit business owners as it could help them choose the borough who would be the best suitable for them. So our project objectives are to learn to clean and organize real-world data, employ data science methodologies to explore the relationship between crime types and their occurrences in different boroughs, generate compelling visualizations and graphs to effectively illustrate our discoveries and insights, create a predictive model to forecast crime types and occurrences in different boroughs of New York City. So this is our team member contribution. So acquiring the original dataset was done by me. Compiling all possible offense descriptions was done by Dakota. Data cleansing was done by me and Dakota. Thorough analysis using and outlier detection was done by Dakota and me. Finding and parsing comparable studies to compare results was done by me and Dakota. Group all code to one repo was done by Dakota. Film a YouTube video was done by me. Coding the decision tree algorithm was done by Dakota. And the visual representations was done by me. So this is the libraries we imported for our project. Here we are reading the data set, and it's included in our GitHub repo, and we just included the link of the raw data set, and we just called the head function so we can see the top rows of the data set. So as we can see here, there is arrest key, arrest date, there is the crime description, there is the borough, arrest borough, there is age group of the criminal, the race, the X and Y coordinates. So for abstract, addressing crime and violations is a crucial challenge for justice. Requiring effective control measures. However, the complexity of big data makes it difficult for humans to accurately and promptly predict crimes. Analyzing crime rates, types, hotspots from historical patterns present a significant challenge to current studies using learning models that lack the desired predictive accuracy. In an attempt to eliminate human interference, we will attempt to create a machine learning model that is able to accurately predict the location of crimes, distribute resources, and statistically justify police presence in specific locations. So feature selection. To prepare the dataset for machine learning classifiers, a series of pre-processing steps were applied to ensure cleanliness and readiness. The detailed analysis of pre-processing steps for each feature is outlined below. The arrest key. This particular feature serves as a unique identifier for tagging each incident. However, in our pre-processing, we utilize this feature to eliminate any duplicate data entries. Um, and we have a arrest date. This feature contains the date of which the incident occurred. Age group. This feature provides information about the age group of the individual who committed a crime. Perp sex. This feature provides information about the gender of the person who committed the crime. Perp race. This feature offers details about the race of the individual who committed the crime. Longitude and magnitude. Um, we got rid of this column because we have an arrest borough which contains the borough where the incident occurred. It is Manhattan, Brooklyn, the Bronx, Queens, Staten Island. And data description. This dataset is valuable for three main reasons. Firstly, it gets regularly updated and checked by the Office of Management, Analysis and Planning. Secondly, it comes straight from the city of New York, making it trustworthy. And lastly, it has a lot of important data points that are essential for training models. These qualities make it a useful tool for various research and decision-making needs. This is the website for our GitHub repo where we put the dataset, the images, and the coding of the decision tree. So for data preparation and cleaning, we named the boroughs names from alphabetical name into their full name because the original dataset had just letters on the boroughs names, like Manhattan was just M, which we thought it might be less confusing just putting their full names. We removed unnecessary columns for the model training to make it faster. We used a subset called NYC for choropleth map visualization by grouping by boroughs names and then counting the number of incidents in each. This is the NYC subset, and I merged it with a shapefile. Um, and here we grouped by the boroughs and the count. And this is the data set we get. So it shows the borough code. This is included in the shapefile. So we got the borough code, we have the borough name, the shape area, and we have the crime rate. This is the coding for the choropleth math and for the charts. So for the line chart, as we can see, we decided to um, visualize by the months. So as we can see, this is Staten Island, this is Queens, this is Bronx, and we can see there's like it's stable. The graph is the line chart is stable. It goes up and comes down. So for the bar chart, we decided to do a comparison of crime rates between males and females. So as we can see, there is a high crime rate on the male side, and this is a comparison of crime rates between age groups. As we can see that most of the crimes are done by people between 25 and 45 years old. And here is the choropleth map, which shows the boroughs with different crime rates, which here we have the Brooklyn is the highest one, and Staten Island is the least one with the crime rates. This is the confusion matrix we got as a result from the decision tree. You have precision, recall, F-score representations. Here we can see that Staten Island is has about like 20% for recall and F-scores. This is a table that shows the precision, recall, F-scores for the different boroughs and their averages. So with the average of 0.348, we can say that this model is overall more likely to predict the correct borough in which a crime took place, um, as a as compared to a random guess. This model is generally more accurate than randomly choosing a borough. This is not the case for Staten Island predictions, in which the precision recall 0.18, 0.18 and 0.16 are less than random chance. This is likely due to a lack of sample size within this category, likely led to an inability to discern unique patterns, as we can see that the least amount of crimes happened in Staten Island indeed. In all boroughs predictions except for those of Staten Island, the likelihood of a correct prediction was almost twice that of random chance. However, when discussing the results for Staten Island predictions, this value drops to less than that of random chance. This chance changes the odds of choosing the correct boroughs from approximately 1/5 to 1/3. Another concern is this process. In this process, the possible feedback loop that this data can create. The police collect the data, and then, if this data is then factored into a machine learning model, it will likely compound on the already illustrated trends in the data. For example, an overall presence in Manhattan may lead to many more instances of Manhattan showing up in the arrest records datasets. If the model is then retrained and on said dataset, it will be fed on inaccurate picture of crime in New York, would likely identify Manhattan far more often and thus justify heavier police presence in Manhattan. From the beginning of this project, we set out to create a model um, that can accurately predict the borough in which a crime took place, given a description of the criminal and crime. To be accurate, we have defined it to mean more often correct than not, or demonstrating an accuracy greater than 50%. Given this definition of success, we were not able to create an accurate model in future experiments. A more sophisticated model type may be included, such as a convolutional neural network. As well, a larger data sample size would be helpful in creating a more accurate representation of crime and crime trends. This is the visualization for relative frequency, and thank you for watching.